So this is like, if you're going to talk about this one first. So the PyData ecosystem is heavily based on Numpy. And Numpy is a library for doing a powerful ND array that has a powerful ND array data structure object. And it has a lot of functionality like broadcasting functions, tool for integrating with C, C++, and Fortran code. And the bad side, I guess, is that it's only a single node, everything is in memory, and it's Python only. It's really hard to get the bytes from the NumPy array outside of Python, even though it's a little bit possible. And NumPy is the base of the PyData ecosystem. So in the bottom, you have Python, and then on the top, you have some core libraries like Python that lets you integrate and let you create an interface, a Python interface for your C and C++ libraries. And then you have NumPy, that is the ND array structure. And all the libraries on top are based on NumPy. So SciPy, Matplotlib, Pandas for Dataframes, Scikit-learn for machine learning, stat models for statistics. Everything is based on NumPy. Networkers for graph analysis, Scikit-image for imaging. So all these tools are based on NumPy. And that's good because all the tools could leverage all the functionality of NumPy. So all the broadcasting functions, all the C and C++ code that it wraps, they could reuse it. And it was great. There was a time that there was a couple of libraries in NumPy that did that, and NumPy was the one who integrated all those small libraries into the one source of truth for that. And then you have the Spark ecosystem, and Spark is a little bit similar to the PyData ecosystem. It's a more general engine, and NumPy is maybe not the most general engine. It's based for scientists, and the main data structure is an ND array. And in Spark, the main data structure is the RDD. And there's some differences, right? Like the RDD was distributed by design, while NumPy is just a single node library. But then, on top of the RDD, you have multiple higher-level APIs like Dataframes, datasets. You have graph interface, machine learning interface, SQL interface. The Dataframe is inside the SQL interface. So it's a little bit similar to PyData. And it started in a similar way. And first, Python had NumPy, and then Wes McKinney came and did Pandas on top of that, and in a similar way. Spark started with the RDD, and now we have Dataframes, and the API keeps growing in every release. One big difference with the Spark is that it has actually multiple interfaces. It has interfaces for multiple languages. So Spark is written in Scala, but you can actually query that from Python and the new R interface. This is a little bit how the Spark ecosystem works. You have HDFS instead of the local file system for your data. You have Jan for your resource management. And in top, you have Spark and some other friends like Pig and Hive and Impala that we don't really talk about it in this conference. But then you have Spark, and you have the RDD there. And on top of that, you have the high-level API that I was mentioning, GraphX for network analysis, machine learning, and SQL that has the Dataframe API. And then on top of that, you have PySpark. So you have this layer similar to what the NumPy ecosystem had. Okay, some of the difference, like I mentioned, the PyData ecosystem is based on NumPy, and the data structure is ND array that is very useful for the scientists that do scientist stuff. They usually they don't know a lot of DevOps, they don't know a lot of Linux, they don't know a lot of Bash. Maybe they just have they use a lot of MATLAB, and now they were happy when they found a free alternative like NumPy that they could use. And maybe they use MPI if they really had to scale to multiple nodes. And Spark was for a world after MapReduce, nobody really wanted to write more MapReduce jobs in Java, so Spark was a big relief for all of us that actually had to write one of those jobs. Both people were relatively fine and happy, and they still are, I think, with the people I talk. The problem was when scientists had to actually start scaling their analysis, and the big data people that do ETL jobs and they do parsing JSONs and passing logs had to start doing statistics and machine learning. They were I don't really know how to do that. And the scientists, they were yeah, I don't really know how to scale that because I know how to do machine learning, I know my algorithms, I know my random forest, neural networks, optimization libraries, logistic regression, all that, but I don't really know how to scale that analysis. So that's when Spark came and actually started solving a lot of these issues. And data scientists now have to basically do both, which is good and bad, because now you have to learn more stuff, and do more stuff. But there is tools that we'll be building, and they're going to keep building to make that easier for data scientists. Some issues with PySpark specifically. The first one I put it like in a light gray, because it's not really that important. But I think it's my personal opinion that the PySpark source is not very Pythonic. And when you have what I mean by Pythonic is that Python is a very nice language to read and write, and a lot of libraries are written in a way that is, we call it Pythonic, that is really easy to extend, it's really easy to dive into the code and submit a patch, submit a pull request, or anything. But the PySpark source, every time I look at it, I like cringe a little bit, and I really don't like it. And it's really not important, because if the performance is great, like whatever, right? But it's actually an issue for like getting the community into that. And I always feel that like PySpark is, like people say that PySpark is like very well supported. I kind of don't agree with that much. I think it's always lagging a lot behind the Scala implementation of Spark. And if the source is not Pythonic, the Python people like me or people like Continuum, we don't really get that excited when we have to actually submit a patch. So that's my opinion. It's not really that important, but it's something that I think we should fix sometime soon if we want to make PySpark easier and better for people to use. The second issue is the package management, like I mentioned before. You want to use all your Python libraries in your Spark jobs, and that's an issue when you have a cluster. A picture, nice. And then the second issue is performance, because Spark runs in the JVM. You have to do a lot of serialization and deserialization with your Python objects. So for example, you have a Numpy array, or a Numpy array, and you want to put that into an RDD. What's going to happen is that you're going to end up with an RDD of a pickle, and pickle is a serialization format in Python. So you're going to end up with that you have to like serialize in your driver node, send it to your worker nodes, deserialize in your worker nodes, do some computation, serialize back when you collect. And that takes a long time in a job usually. When you start benchmarking that, it takes a really long time. And the second one is that it uses Py4j communication. It's a similar issue. Of course, you cannot like I mentioned, like accessing the NumPy information inside the array is really hard to do it outside of Python. So you have to start communicating and pickling and pickling all that information. So PyData package management. Like I mentioned, there's been a history of issues with that. Basically because NumPy and all the tools that I mentioned before, like SciPy, Scikit-learn, they have a lot of Python code, but they also have a lot of C, C++, and Fortran code. Especially NumPy and SciPy are the ones that have most. And this is a problem because, well, if you have C and C++ and Fortran code, those are compiled languages. You have to compile that. And compiling is really annoying when you're a Python person, because you usually don't, because Python is an interpreted language. And the big issue is compiling on Windows. You might even get compiling something on Linux. You install GCC, you do all the libraries, you do you link everything, and then you're fine. But on Windows, if you have to do that, you have to download all these Microsoft tools. It's really annoying. So that's one of the main reasons Conda and Anaconda exist. So Anaconda and Conda. So Conda is a language agnostic package manager that is going to let you compile your code in locally, create a binary file that you can ship to another laptop, another station, another node in your cluster, and then you can extract that binary and reuse the library there. And Anaconda is Conda plus a lot of libraries that Continuum builds, like NumPy, SciPy, Panda, Scikit-learn, and all that stuff. And I have a story about this that is a little bit funny. When I was in college, this didn't exist, and wheels didn't exist in Python either. And the only way to install NumPy and Panda was to compile it, actually. And back then, I was using Ubuntu, and I actually compiled that, and I put it in a USB stick, and I started selling it to people, for $5, because it was really annoying to compile it. And it was not the most relocatable package ever, because I compiled it locally, so people had to put it in a very specific location. But I make $100 that way. Yeah. And then Anaconda came, and they actually basically screwed me over, I guess. I was going to get rich. So basically, yeah, who here uses Anaconda? OK, a lot of people. Awesome, great. So I don't have to explain what Anaconda is, I guess. It's great Python distribution. And now the new thing on Conda is Conda Forge, that is community power packages. So Anaconda is, all the packages in Anaconda are built by Continuum. Even though it's free, you can just download it and use it. And the recipes are also free, but the build is kind of like Continuum only. But Conda Forge is a community power movement to actually reuse all these recipes and make them available. So it uses Travis CI, Circle CI, and AppVeyor to build these packages on the open, and it's really, really great. Continuum is also sponsoring a lot of that. So we have a couple of developers working on that and submitting recipes to Conda Forge to actually open everything that we have. And then you have like package management in a cluster. And it's not really a new problem for DevOps people or configuration management people. You have a cluster, and you wanna get there. You basically SSH, right? You SSH and you like do apt get or conda install, blah 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 blah. When you want to do that, like in 1,000 nodes, it gets really annoying. You can have a bash script that SSHs to all the nodes. You can use Fabric or stuff like that. But there's also like more powerful tools like Salt for Python and Chef in Puppet, and Chef and Puppet in Ruby. Ansible is another option in Python. And basically what that does is installs a small service in all the nodes. And from a master node, you can say, OK, all these nodes, I want you to install this library from apt on Ubuntu, for example, or Geom on Red Hat. And you can do that, and you can write custom modules for your Conda modules, for example. And if you search on GitHub, you're going to find a couple of them that are freely available for Conda. So if your IT people are using one of these tools, you can like link them to that and tell them like, yeah, you can manage Anaconda in all my nodes using the tools that you already have. That's nice for a lot of deployments, but it's also a little bit of annoying if you don't use those tools, right? And a lot of people for Hadoop clusters use Cloudera Manager or CDH for distributing and installing their Hadoop distribution. So what we did was to create an Anaconda parcel for CDH. And that was a joint work between Cloudera and Continuum. We worked with Cloudera to make this happen. A shout out to Juliet that helped us a lot with that. And basically, Cloudera is the most popular Hadoop distribution. I know that I deploy Cloudera a couple of times every week. I love it. It's the best. And what Anaconda is a static Python distribution, the same distribution that you have locally. We put it into the Parcel format that Cloudera supports, and it's super easy to install. You just have to like go to your CDH UI, you do a couple of clicks, you put an URL, and it's going to install Anaconda in all your nodes. And then you can target Anaconda's Python inside your Spark job or Hive if you have an UDA for stuff like that. So it's installed in all your nodes. That's nice. What if you don't use Cloudera, right? Not everybody uses Cloudera. Some people do Hortonworks. And if you wanna, I kind of wanna make the Hortonworks plugin happen too. We just need somebody to actually maybe sponsor a little bit of that. So if you want to make this happen, if you really want to have Anaconda in all your nodes and your company has Hortonworks, so call me maybe. And what?
Is that $5?
No. I'm gonna send you a link to my sales representative. Yeah. It depends. Like Anaconda Parcel is also free. I forgot to say, like you can get it for free. It's a static distribution, so if you want some extra package, for example, I don't know, TensorFlow. If you were here for the meetup, like on Monday, you saw that there is new Spark-frames, and you need to have TensorFlow installed in all your nodes. TensorFlow is not in Anaconda, so we can create custom Anaconda parcels for your cluster if you want that. That part is not free, of course, but the base Anaconda parcel is completely free. So we want to make this happen for Hortonworks. We want to make it free. So yeah, and also you can maybe manage your own Hadoop cluster, which is like really, really annoying. I don't know why will you do that ever, because I know that I did, and I know that it was not fun. But for solutions like that, we have a tool that is agnostic of any deployment. You can deploy it on the cloud, on premise. You can deploy it in an air-gap environment. if you pay us a lot of money, more than $5, is dynamic package management and environment management. So something important I forgot to say about Anaconda is the environment management. So all these libraries are based, are like super relocatable, and you can install it on custom environments. So in one environment, you could have your Python 2 legacy code, and in another environment, you could have your new code using Python 3, and all that works seamlessly in Anaconda. So the Anaconda parcel doesn't support that. It's only Python 2, and it's static. You should really don't try to use Conda from that because you're going to have a lot of issues. But then Anaconda for cluster management, the tool that we built to actually do dynamic package management. You can install new libraries. You can do environment management, and all the good stuff that Anaconda gives you. And it's a CLI tool. You can do like a cluster Conda install, blah, 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 a cluster Conda create, blah, 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 and it's going to be the same as the Conda environment, as the Anaconda that you know locally. This tool is based on Salt. Like I explained, it's a small service that you install in all the nodes, and it lets you control all the minions, like they call them. And it has some extra plugins, like the Jupyter Notebook. So a lot of people in the PyData ecosystem use the Jupyter Notebook instead of Zeppelin. I've seen a lot of Zeppelin in this conference, but Jupyter Notebooks are like an alternative. And they're probably the one that started like this HTML data analysis notebook trend that we've been seeing recently. So it has some extra plugins to do easier integration with the PyData ecosystem, but that's it. There's also new ways to install Spark, install your environments and your packages in Spark. And once you don't really need this new service, Salt, installing all your nodes. If you already have a Spark and you already have Yarn, especially running, you can use Yarn to actually deploy your Conda environments. And this is a tool that somebody built on GitHub, and it's called Sparkonda. And what it does is basically uses Spark to deploy your Conda environments. And it's really, really great. You create an environment locally, and then you add a Python, you add a py file to your Spark context, and then you tell Sparkonda, okay, this is the environment that I want to use. This is the location where it is. This is the executors, the course per executor, and then you tell them, okay, pack this environment and distribute it to all the nodes. And then you say, like, install the Conda environment and set the Python worker interpreter to that Python interpreter that I just shipped in that environment. And then you can just check that, for example, Pandas was actually installed on all the nodes when you run your job. So this is a really great tool because you don't need anything. The only thing that you need is Yarn. Actually, you don't need Yarn for this. You just need a Spark. If you're running a Spark standalone, you can already do that. And you don't really need to install Salt or any other tools. And there's also some beta work that a coworker of mine did using Yarn. This one is using Yarn especially. And the big reason we did that and we started doing that was because we started looking about the security and how can we disable people from installing packages that are not from very specific locations and stuff like that. So we're trying to use Kerberos to do all that stuff. It's still a work in progress, but it's something that we have been working because when you get into the enterprise, you start having a lot of security complaints when you're not compliant, right? Okay, once you solve your libraries issues, you have Anaconda installing on your nodes, you can start doing PySpark. And this is like the billionth time that I have seen this word count. And every time I see this, and every time I see it in a meetup, and I go to a lot of Spark meetups, it makes me a little bit sad because I will never do that in Python for real. I will never write word count using just Python. I will probably use something like NLTK. So now that I have Anaconda installed in all my libraries, I can leverage all these libraries and actually do analysis using these libraries. So I do some word tokenizing and do some part of a speech tagging, and then I just map it to an RDD that I created before this. So this is a more real, probably word count and NLP example that you can do really, really easily leveraging the Python libraries. I'm going to skip this one because I don't have a lot of time, but it's basically the same using SciPy and other images, and other libraries to do some image analysis. It also uses the GPUs in Numpy. That is a library that we built. It's also free. Numpy lets you compile Python to target multiple architectures, and you can target GPUs. And another nice example, and this this is actually funny because when I submitted this talk, I had a library similar to what Spark Scikit-learn is. And Spark Scikit-learn is a library that Databricks released a couple of months ago to do grid search, grid parameter search on Scikit-learn models. And I had this library that was really hacky that basically did the same thing. But then they released this, and then I was like, OK, great. I don't really have to maintain this anymore. And this is like a really nice example of how you can do how you can have like a local Python code, because this is just Python right here. This runs using Scikit-learn in a local node. And you can reuse this in basically all this code by just changing the import line of the grid search. So this one line that is involved right there. So instead of importing grid search for Scikit-learn, you import it from Spark Scikit-learn. And then you do a parameter grid search in a lot of nodes instead of just one node. And machine learning people know that this is basically what they do a lot of times. Just give me a lot of parameters and do a grid search and trying to find the best match for my data. There is work done to be here. As you can see, I have the data locally. The x and y variables that I have are local, and they have to be shipped to the worker nodes. So it will be really nice to actually read data from HDFS on the worker node instead of just shipping the whole thing. There's some issues about balancing the sample that you get from the data, because if you have if you have a classification problem and you have zeros and ones, you want to have 50% of zeros and 50% of ones. You can do that once you have everything in memory, but you cannot do that once you have it on HDFS. So there's work to be done here, but this is a really nice library. The code for this library is very Pythonic. I really like it. I approve it. I give my seal of approval. And then you have Dataframes. And Anaconda people who use Anaconda and Python know that Pandas is probably the best thing that happens to them. And Spark Dataframes are also the best thing that happened to me personally in Spark. And not only because the interface is really nice, that it is. It's very similar to Pandas. It's still lacking a lot of functionality, but it's going to get there eventually. But it's also very performance happy. So if you have data that is columnar, you can put it into a data frame, and it's going to be way more performant than an RDD of Numpy arrays or Pandas data frames. So this is like a nice tip that I always give to people when they say that the PySpark code is slow. Maybe use data frames, and you're going to be much happier. And a little bit about the future, and maybe some alternatives to Spark. The future, there was a really nice talk by Wes McKinney, who actually started Apache Arrow yesterday. If you were there, you did it right. And if you didn't, you should go and check the video. And basically what it does is a columnar in-memory format. So in the left, you have the world before Apache Arrow, and on the right, you have the world after Apache Arrow is going to get integrated in all these projects, hopefully soon. And I know that I have converted a lot of data using HDFS and Hive jobs, like way many times that I should have. And Apache Arrow is really, really exciting. And this is going to reduce a lot of deserialization that is going to happen. Because if you look at the top right, top left corner, you also have Pandas there. And Pandas is kind of like an outsider in between Drill, Impala, HBase, Kudu, Parquet, and Spark, because Pandas is like a Python-only tool, right? And all these other tools are part of the Hadoop ecosystem. So it's really good to see Pandas there, but it's really, really exciting for the Python people to see it there, because we're going to get a lot of performance from that. And also TensorFlow, it's a really nice library that Google released last year. And it's basically for machine learning, for deep learning. I'm not going to talk a lot about this because there's been talks about that. But the nice thing about this that people don't really talk is that it integrates really well with the Google Cloud platform. And that platform, nobody really talks about that. A lot of people talk about Microsoft Azure ML and Amazon AWS, but the Google Cloud platform is actually really, really good. It's personally my favorite platform for doing all this kind of stuff. And TensorFlow integrates with that. And finally, there's a new library that we have been working on Continuum. It's called Dask, and it's parallel computing for library analytics. It's a little bit similar to Spark. It's trying to target not only the distributed case, but also single node but multiple cores, a big workstation that has a lot of memory and a lot of cores to do processing. It's based on NumPy and Pandas, and it has an interface that is really, really similar to Pandas. And you can install it on distributed way using DC2. So you should really check that out if you want to leverage more PyData tools instead of having to serialize and deserialize a lot of data from Spark to Python. And yep, that's it.
Excellent. Do we have any questions? I see one over here.
Thanks a lot. You're doing lots of great stuff with Python and so on. I have a complaint, though. Downloading Conda, the way that it's advertised on the website to do it, is just a plain download this shell script and run it. And after that, maybe check the MD5 on it, which is like after your entire system has been owned. So I complained about it a couple months ago. Nothing has happened. I tweeted today. Can you start with a good foundation of installation security? The update framework is actually a fabulous way to do this. And as we heard in the keynote this morning, people care about security. The banks don't want to be
yes,
doing
definitely.
That
Security is one of the things that we've been targeting a lot recently. So I'll talk to you later more about that for sure.
Any other questions? Over here.
So my question is about how Conda and pip interact. Like sometimes Conda doesn't have all the packages, and you install with pip, and it's a different version. And any advice on that?
So basically, my recommendation is if you have it on Conda, install it on Conda. But Conda, in a Conda environment, you already have pip. So any other library that we don't have a package for it, you can pip install it. And once you have NumPy, Pandas, and Scikit-learn, and all these libraries that are hard to compile, all the libraries that are on top of that are really easy to pip install them. They integrate perfectly. You shouldn't really have any issues. Once you have a Conda environment, just pip install, and it's going to work fine. Yeah.
Hey, thank you. You briefly mentioned the serialization, and the serialization is a bottleneck. Don't transfer data between JVM and Python.
Yeah.
I just want to ask, are you aware of any work in this area which may, cancel this? Because this is a real bottleneck when you want to use whatever in a scale. Thank you.
Yeah. Like I mentioned, the easiest solution if you have columnar or tabular data is to put in a data frame and then start applying Lambda functions to those, because then you're not going to serialize from Python objects to Pickle. But it depends on your use case. Unfortunately, it's something that it happens. Like I say, Arrow is probably going to solve some of those issues in the future. It's not there yet, but yeah.
Yeah, if we put containers in our cluster and have virtualized Spark containers, and you didn't talk much about Anaconda Enterprise Cluster, about maintaining the virtual environments, and how do you get those notebooks to point to those, and enabling the end user to install whatever packages they want.
Yeah, so we have a couple of things, like Anaconda for cluster management is going to manage your environments only. We are not going to help you with pointing the notebook to that, but you can start a notebook on that environment, and it's going to use that Python, the Python libraries that are on that specific environment. I don't know if that was your question or not.
Is that inside the container, though?
It's inside the Conda environment, yes. Oh, the yarn one? Yes. No, it's not a Docker container, but if you run it inside of yarn, we're going to install it in the yarn container. That it has a directory where you install all your local data. We're going to install that there. If you're talking about the yarn integration that I mentioned. Oh, we'll talk later. Yeah. Okay.
Hi, this is kind of a basic question. So we're kind of more in the evaluation stage, and we're kind of trying to figure out whether we should go all Python or all Scala for this. From what I can gather from your talk, it seems like there's a lot of stuff with Python. Is there, from your perspective, would you recommend just going with Scala just because of the better feature and support there, if we have no current love for Python or Scala right now?
So yeah, if you have no love for Python, you're probably not going to have a lot of advantages from using PySpark. It's always about the tooling. It's not about the language or the libraries. It's about the tooling, because if your company has a lot of people that know Eclipse and they know how to debug Java and Scala code, then the best solution will be to do some Scala Spark, right? If your company has a lot of people that don't know Java, they don't know the tooling around that, they don't know Maven and they don't know that, but instead they know Anaconda and they know Python and they know IPDB for debugging that, then it's easier for them to use PySpark. So it's not about the language, it's more about the tooling around that that takes more time to get used to. If you're not used to either of us, of those, I would recommend Python because I like Python. It really, really depends on the use case, but we can talk more about, yeah.
All right, excellent. Let's give one more round of applause for our speaker.